Hi, and welcome to the FireDAC Skill Sprints. My name is Damien Bootsma, and I'm a software consultant based in Sydney, Australia for Embarcadero Technologies. This is my very first time doing one of the skill sprints, so I'm pretty chuffed to be asked to help out. And for the next 20 minutes or so, I'll be taking you through the monitoring and tracing capability that is available within FireDAC. So we're going to be talking about tracing, monitoring, and metadata. This is just one of the interesting components of FireDAC. When we typically look at a database connectivity API or component suite, we typically look at the standard CRUD operations. But what's really cool about FireDAC is we have a number of components that are devoted to the debugging and logging of output of the communication between the application and the database that you're using. So tracing provides a detailed log between a FireDAC application and the database management system. It's going to give you all the details about when the app talks to the database and the SQL that's being submitted to the database, the results that's being returned, and that sort of information. What that does is put that in a log file. We also provide the ability of being able to monitor in real time using the FireDAC monitor that's part of the IDE. We can use that to connect up to the application and then monitor the real-time communication between the database and the application also. What we also have is environment reporting. Very, very useful for when you're dealing with Embarcadero support, but also your own customers in trying to ascertain the environment and how it's configured. And so this environment report provides information about the database management system connection that you currently have in the application. And finally, we have a variety of metadata that we have access to. And this gives us access to the DBMS object detail. So we can get information about the database management system drivers and the version numbers and the database we're actually using. But we can also really get down into fine level detail about the schema and the associated schema objects that we find within that database also. So, as I said, in the next 20 minutes or so, we're going to try and get through most of this information and have a look at the support within FireDAC for these capabilities. But first, before we look at them, why consider using them? Why is something like tracing, monitoring, and metadata useful? First and foremost, for me, when I thought about this, the first thing that came to mind is it's extremely useful for debugging and troubleshooting. If you're building software for a number of customers, to be able to get all that environment information up front, to be able to understand how the database is communicating with the application, is a great insight into what the problem the customer might be having. So that's first and foremost. But also when you're dealing with Embarcadero and FireDAC support, this information becomes a very, very powerful way of being able to quickly resolve the problems that you might be having. Now, the thing with the tracing and monitoring and this active approach to it does incur performance overhead because we are effectively logging all the traffic between the application and the database layer. So we don't want to have this on constantly. Perhaps what we can do is implement a dash debug mode for your application. So if we are experiencing this problem, you're able to run the application up in dash debug so that we can enable the logging support within FireDAC so that you can perform the particular action that's causing the issue and it either writes it out to the log file or we can actively monitor it as well. So just some consideration there. Very useful for debugging and troubleshooting, but not wise to have this run constantly within your application. So let's have a look first at FireDAC Tracing. FireDAC Tracing is effectively writing out the database management system activity to a log file. So as you're querying and inserting, communicating with the database via your application, all that activity is being logged to a log file. The way this is being done is we add to our data module a TFD monitor flat file client link. Within that component, we can then determine the different types of events that we want to log and the verbosity of that output as well. So I'll show you those properties that we can set on this component that we can determine what events and how verbose we want our log file to be. We can also determine the location of the log file as well. Something really simple that we can pick up and email over to support so we can ascertain what the problem might be. Once you've configured that particular component, what we then do is jump into the connection component that we're using, and it has a monitor by property, and we set that to flat file, and by setting that to flat file, we'll be able to get up and running with that TFD connection and start our FireDAC tracing. We would then go in and run the application, perform the work we're after, and on closing the application, the log file would be made available to look at. So let's have a bit of a look at an example of that right now. So I've got a little FireDAC and FireMonkey application here, just targeting Win32 at the moment. And it's made up of a little data module and a front end. In my data module, I have my TFD connection. This is actually a connection to a little mobile application I've written for football coaching. I'm a mad football coach, so if you'd like to see client details on that, please let me know. But this is just communicating to one of the tables in my database. So I've got here my FD connection. I'm querying my player table, so I have a TFD query for that. And what I've also got here is the standard FD GUIX weight cursor component that we require. And also my FD monitor flat file client link. So if I just quickly go and have a look at my client link to begin with, you'll see here I have event kinds. So these are all the events that we can go and trap for and store within that log file as the application is running. So we have quite a number of these. So you can choose to turn all of these on or select a number of those particular events. We can choose whether or not we append to the file or rewrite the file each time the application runs. And then we can determine as well through file columns what level of detail we want to include in this. So do we want to include the line reference number, the time it occurred, the thread ID it was running in, the class or the component that was executing from, the object ID, and any messages as well. So again, just for the sake of the demonstration and the code sample, I've just switched all of these on for us. And then the all-important file name. We're actually going to write this out to. And just to make it nice and easy, I'm just writing this out to c:temp soccermanager.ib.txt. So these are the values that I need to have enabled in here. In order for my application to realize that I'll be using this flat file to log my output to, I need to go open up my connection. And within my connection component here, I set the monitor by property, and we set that to flat file. Okay, so by setting that to flat file, it's going to look for this component and then log out for us as we go. So this is just stored within my data module. Within my application itself, I've got here just a tab control with a tab item. Within this particular tab item, I have a string grid that I'm storing my columns and rows within, and I have a little button over here called Get All Players. And if we just quickly have a look in Get All Players, what I'm doing here is I'm setting the tracing on the monitor flat file component to true, and I'm setting the dataset active from the bind source. So if we run this up, I now have my little FireDAC monitoring application here. I'll choose to get all players, and I can see here this is written out. I've got my son in here and other names to protect the innocent. Test players 1 through 9, shirt numbers, team identifier, and so forth. But when I close this down, I'll get a message here saying that FireDAC has produced the following application trace file, soccermanager.ib.debug.txt, and I can go and have a look at that now. So if we go just into our Windows Explorer and we just jump into temp, and I come over to Soccer Manager IB, we just maximize that, we can see here the dump and all the logging that's occurring here. So I can see here that I'm talking out to this particular database here. I can see the username that I'm using and the password, perhaps the protocol, the server that it runs on. I can see here the line number, the time that it's executing. This is Australian Daylight Savings Time. I can see the component that it's executing from. And as we go down into the details here, we can actually start to see some of the SQL that's being used. So here I can see my FD query has been executed, and I'm about to prepare a statement which is effectively select star from player, and I can see that, and I can see the process that we go through. And this is something that my customer can share with me, that I can pass on to support if there's an issue being displayed within the application, and I have all this relevant information at my fingertips to help ascertain what the problem might actually be. So this is the flat file support that we have within FireDAC, and being able to log that to a detailed log file. The second thing I wanted to discuss, which is very similar to tracing, is monitoring. It's providing very similar details, if not the same detail as flat file tracing, but it's an active monitor approach, where what I can do is run up what we call the FD monitor, the FireDAC monitor. You can run this up from the tools menu of RAD Studio and see that running. But in order to access and use this particular component, what I do is I add in the TFD Moni remote client link. Again, I determine what events that I'm going to be logging to, but instead of displaying a file name that I had to do previously, I set the host and the port number of where I'm going to be monitoring this application from. So I set those properties in the T-Moni remote client link. I then set monitor by equals remote on the TFD connection. Previously, in the last example, we had that set to flat file. I now switch this to remote, and then I start the FD monitor. Once the FD monitor is running, I kick off my application. We'll be able to connect up to it, and as I'm performing actions within the application, we'll see the corresponding DBMS output being displayed within the monitor component itself. So let's have a brief look at that as well from that same code sample. So again, if I go over to my data module, I now have another component down here called the FD Moni remote client link. Like we had before, I'm logging all the different event kinds and capturing those events. And then what I'm doing down here is specifying a port number and a host name for where my monitor resides. And I'm just running all this on a little virtual machine, so it's pointing at localhost, and the port number is 8050. That was the available port, and happens to be the default port that is set up for this particular component. Setting tracing to true also. So again, if I go back over to my FD connection, what we'll do is we've got the monitor running there. We'll go and change our monitor by, and we'll set that to remote now, and click OK. We'll rerun our little application. And what I've also got here is from the tools menu, I have something here called the FireDAC monitor or the FD monitor. And this is this little application that's running here. So I can see now that I've run it up, and it's showing me that there is a connection to an application, and this is the client now. So I can see that. And we can go over to my application, and again, let's call get all players. And notice the moment that I've clicked on that and to display all the player information, I'm getting that detailed output in real time via the FireDAC monitor. And that's showing me all the detail that we're capturing and the objects we're communicating with, and the SQL that's being passed between application and database. I can also see any of the application objects that are being used from the data module. So this is DM IB test. I can see my connection, my FD connection here. I can see the database that I'm using, the client libraries, the DLLs, the server version, and so forth. So it's quite useful to be able to see this information and again share this. This could be a valuable way of how you can communicate with your customers if you have access to their network, and providing effectively remote support in a very interactive manner. The third option that we have is custom FireDAC tracing. And custom FireDAC tracing gives you the ability to define a custom location or a custom format that you would like these logs to be written out in. In order to use this capability, we use the TFD Money custom client link component, and with that component we implement an on-output event. And with that on-output event, we define how we're going to write out that logging information. And then what we do is, again, as you saw with the flat file and the monitoring support, we set monitor by to custom this time on our FD connection component and set tracing to true. And that will enable us to write a custom output for our FireDAC tracing. So they're just some of the examples of tracing and active monitoring within your applications. But as I said, there's a number of other things that we can provide that gives us information about the communication and the details of the database that your application is integrating with. The second thing then is what we call the FireDAC environment report. This environment report gives us information about the vendor of your database, but also specifically the driver that you're using for that database also. Very useful now when we're in the world of 32-bit and 64-bit systems and managing upgrades, being able to figure out which driver is appropriate to the hardware that you're using. We can also extract out the connection properties to that database. Am I using the right username and password at this stage? But I can also pull out the appropriate FireDAC version information as well. The classic example of a particular database being supported in a newer version of FireDAC as opposed to an older version of FireDAC. Being able to have that FireDAC information will help us quickly determine whether or not the version of FireDAC you're running with has support for that particular database. There's a number of ways that we can generate this environment report. When you're in design time within the IDE, you can double click on your TFD connection component and go over to the Info tab, and that environment report is there straight away that you can access. You can also do a similar thing via the FireDAC Explorer utility by being able to do choose the particular connection and access the info from there as well. But you can also call this in code by calling get info report on your TFD connection. Be able to write it out to the application also. So I've got a very simple example of that third option there of get info report that we've incorporated into that sample code also. So let's take a quick look at that. So if I go over to my front end, I have my second tab item, which is called my environment report. Within here, I just have a T memo, and I've got a little button up here called environment report. And if we go and open up environment report, all I'm doing is referring to my data module, accessing my connection, and calling get info report. And what I'm passing into get info report is memo environment.lines. And at this point, that will write out that info report for us. So again, if we go and run up our application, and we're on our environment report now, and we click our button here, you'll see here, let me just make this a bit bigger, we can now see information about the database. We can see our database that we're using, the username, password, the protocol and server for where this database resides. I can also see the driver ID, so I'm using the IB driver for FireDAC. I've then got the FireDAC information. It's being pulled from RAD Studio XE7. This is the build of FireDAC that I'm currently running. It says here I'm executing on a 32-bit platform. And then I can also access here the driver of interbase that I'm using, the version number, and where that DLL for the driver resides also. And any other session related information also that we can get in that environment report. Again, really useful for passing on to Embarcadero and FireDAC technical support so we can assist with any problems that you might have, but also for your customers to run up this report and send it back to you also. Again, being able to provide that interactive support and first line support for your customers also. So the final piece I wanted to talk about was FireDAC metadata. Now, we've seen a little bit of this already through the environment report and also some of the monitoring details when we brought that up. But some of the simple FireDAC metadata we can access via our connection component is, again, things like the vendor of our database, the client and the server version numbers of the database and the drivers that we're using. But one of the things we can do, and this is where I sort of see the true details for metadata, but we can actually get access to schema objects for that database as well, which is a really powerful thing. It's almost moving into the administration component of managing your database as well. We can access this through the connection metadata in INTF call, and we can get information about our metadata from there. And I'll give you an example of that also. So we'll flip back over to our design view and to my third tab, which is just DBMS metadata. Again, I've just got a memo component here. I've got a button here called DBMS info. And if we open that up, I've just done a couple of things with this here. So the first thing I've got is I'm just clearing out the memo so we can start from scratch each time. From my connection, I'm calling the connection metadata INTF property, and that's going to return for me this type here called DBMS metadata. And DBMS metadata is an interface, this IFD Fizz connection metadata. Okay. And with this information, I can pull out details like the kind. So DBMS metadata.kind will give me a list of different database vendors that I might have. Now I know I'm using Interbase here, so I'm quickly just going, if the DB kind equals MK Interbase, then I'm going to spit out here DBMS kind is Interbase. Following on from that, using that DBMS metadata, I'm going to pull out the server version and the client version of the libraries that we're using to communicate with Interbase. So we can pull those values out. Now this is the other really powerful part of the metadata that we get from FireDAC, because this is all related to database connectivity. But this final piece is actually giving me access to the schema of the database itself. And so from that DBMS metadata object, I have a number of calls that I can make, and one in particular that I've pulled out here is called get tables. And what I'm doing here is I'm defining, there's a number of parameters in here. The first one is determine what sort of tables, if they're going to be system tables or the tables you've created, if they're tables or views, and a number of other things such as catalogs and so forth that don't particularly apply to Interbase. But I can specify these, and this returns for me an object called meta objects. And this is of type TFD-S view, which for all intents and purposes is effectively a data set that I can sort of iterate over and have a look at. And I've just quickly iterated over that to pull out the different sorts of metadata that we could extract out once we have this particular object. And I've just wrapped this up in a try finally, so that I can free my DBMS metadata here at the end as well. So if we run this, and we're on our third tab now, we call DBMS info, I can see it effectively is an Interbase database. I can see the server version and the client version. But some of the additional metadata that I can pull out here is catalog name, schema name, I can pull out table names, I can pull out the types of tables they are, and the scope of those tables as well. So I can iterate over that information and pull that out also, which gives me really detailed support of the underlying database objects found within the schema of my database also. So to summarize what we've seen in this skill sprint, first thing is that FireDAC Tracing and Monitoring provides you with really in-depth DBMS communication details, really giving us the ability to understand how the application is communicating with the database. So if we have a problem, we have all the comms between those two layers to help identify what the problem might be. To help understand the configuration of the database and how it relates to the application, we have the environment report. And that gives me details about the database itself, but also the version of FireDAC that I'm using. And we can access that environment report a number of ways. We can access that through the connection component at design time. We can access that through the FireDAC Explorer, but we could also access it in code via the connection component also. And we have a whole range of metadata available to us to give us insight into the database that we're using, but also the database objects that are contained within there also. And these tracing and monitoring capabilities really give us assistance in troubleshooting and debugging our applications, not only for your customers, but also so that we can work with you, so we can help you build quality software for your customers also. Well, it's been absolutely brilliant presenting to you. Thanks for your time. I certainly hope you found that useful. And if you've got any questions or comments, please email me at damien.bootsma@embarcadero.com. I've also got a Twitter handle, Damien_Bootsma. Certainly follow me for all things programming, surfing, and football. Certainly love to hear from you and get some feedback, seeing this is my first time doing a skill sprint. I'll be online for Q&A as well after the session also. Thank you so much for your time and looking forward to presenting to you soon. Cheers.
Okay, and with me on the line is Damien Bootsma. I think he's probably almost 1:30 in the morning in what is that, Eastern Australian Daylight Time or something like that?
Yeah, that's right. Yeah, 1:27.
Yeah. And Pavel Glavatsky from Amsterdam. We've got the planet covered. We got Europe, Australia, and here in Scotts Valley. Pavel, are you there?
Yes, we are all covered around the world, so we are ready to handle questions from all around the world.
Excellent. Damien, there was one, I think Joseph, Joseph was asking, are you going to make the sample code available? And I think the slides would be great to make available as well.
Yeah, no worries at all. I might just sort of add a few comments into the source code and get that cleaned up, and then, yeah, we can email that out to the attendees or whoever's interested in it. No worries at all.
Okay, put links on your blog, or you can send them to me. I can put them somewhere as well. No problem.
Cool. Yeah. No problem.
And then Bjarne was asking about you talked a little bit about the fact that you're connected to the database when you're monitoring, tracing, and so on. He was asking, what if you're dealing with 1 million rows? What if you've got a lot of database operations going on? What's going to happen is not only performance-wise, but what do you do with all that data?
Yeah, I think in the log file itself, it's not actually giving you every line of data back, but it's giving you sort of the row sets that are being returned. So you can sort of see that information. But we've got access to those events and the verbosity in the log file, so you can choose what you actually want to see come back in there and control the amount of detail going to the log files or what's actively being monitored. So you can tune a little bit of that to a certain extent.
And then also you showed the custom monitoring where you can choose more, right, of what you want to save or look at or not. Yeah,
exactly. Yeah, so one of the arguments you've got in that custom monitor output on output event is sort of all about line information. So you can extract out what you want from there and then write that out to a file or to any sort of visual component if you so wish. So you've got a little bit more control with the custom monitor component too.
And then Raymond was asking about if you're doing multi-tier operations, for example, with DataSnap, where the DataSnap server is talking to the database, can you also do monitoring there? I mean, you can monitor the database operations, not the DataSnap interactions back and forth. Right?
Yeah, that's right. Yeah, from the client point of view, if they don't, I mean, it's being surfaced by the DataSnap server, so it should be okay. I've probably got a question mark around whether or not it can write the log file to the client side. Yeah. But you should be able to, from the client, be able to surface some of that monitoring support. But I don't see that being a huge issue. I might run some tests on it, but I don't see it being a big problem. What do you think, Pavel?
Yeah, I think that's probably the point of having the monitor. You can have the monitor application. It's just listening on a certain IP address, so you can potentially actually send the tracing information from the server to the monitor running on a machine that you have access to, given that you have all the security in place, so you can really reach to it. But otherwise, you can also possibly save this log information and maybe make it available to your clients through some custom server method or something. So I think there's lots of possibilities to get this information from the server available to the client.
That's what I was thinking, is that you could do the monitoring in the DataSnap server or in a DataSnap server, and then provide an interface, package up that that trace data, monitoring data, and provide an interface where the client application would call to the data snap server, as you said, or through some other interface. The only other thing I thought about is, of course, making sure that using different IP addresses for your data snap server versus your monitoring, but that's the same as trying to find any open port. Let's see. I'm not sure this one, there may be a typo in this. Raymond was talking about metadata tied specifically to the database and metadata differences. How do you deal with, if you're talking the interface versus Advantage Database Server versus Oracle versus MySQL and so on? I mean, you can test to see what database you're talking to, right? Because you know the database connection, the database type, and even the client level of what Oracle server, for example, you have out there that might have some differences between versions of Oracle. I'm not an Oracle expert.
Yeah, I mean, there's a couple of things I noticed when I was looking through the code. I mean, particularly when you've got, say, an Oracle database, you sort of talk in terms of schemas. Yeah, that's one of the optional parameters, or you can leave it as an empty string if you're dealing with something like interbase to get back a set of database objects. So while FireDAC makes it generic to go and talk to the underlying metadata itself, it does make some considerations when dealing with certain database types. It tries to deal with generic database object types, as you saw from that little sort of dataset table, with things like you know, tables and views and indexes and primary keys and so forth. So it will basically sort of defer to the underlying driver to sort of get that information back for you. So it remains relatively independent, but via the driver you can go and access specific Oracle types, for example, or something like that too.
Yeah. And Peter was saying, gee, if he's got an Android or some other client app, can you get an information about what's going on in the data? And as we talked about with DataSnap, you could also put the monitor component down, and again, it's an IP address. So if you can get from your mobile device or any device or desktop or server, to be another server, to the IP address of where you're monitoring, then you can listen in on what's going on. So, and then, I guess if everything is local, because Peter goes on to say, for example, if he's got IB Lite and he's connecting locally versus FireDAC, then you can do local monitoring to a file or do a custom monitor completely on your mobile device in your application, right?
Yeah, absolutely. I mean, that's the beauty of FireDAC too, that it is cross-platform. And if you're running something like IB Lite or IB2Go, there's a specific driver for that in FireDAC. So yeah, no, that's a great little thing.
Yeah. And let's see. Kenneth was asking, and I think you covered this, if when you're using the monitoring tool, when you turn on and off monitoring, then there's no extra load, right? When you disconnect the monitoring tool. Is that true or false?
Yeah, that is correct, yes. Yeah, I think once you set sort of the tracing back to off, then the application is not sort of capturing or logging any of that information, so you should be right. That's why I sort of discussed the idea of having like a dash debug mode for your application, so that you can just sort of pick that up in the main argument and then determine whether or not you want to run tracing or not.
Yep. And then take a look at Bjarne's request. He was looking for a good pagination example, and maybe there's a link that you can put in the notes or blog.
Yeah, absolutely. I might even have a chat with Dimitri on that as well and see what we can put together. But yeah, that seems like a very good example and something we should have a look at doing.
Yeah, Frank's asking, can you filter only the SQL statements? I guess in the custom version, you can do all sorts of things. Choose what you want to take a look at. I know you can get the SQL statements, and
yeah,
you know if there's an option just for SQL only.
Yeah. I mean, you could use the custom monitor just to sort of pull that out. That shouldn't be an issue as well. And if I go and have a look at the event kinds, you've got, what have we got here to have a look at? Command execute is probably a good one, and that will give you the SQL that's sort of that will currently be executed. So you could even just sort of filter out and look for that specific event type as well.
Robert asked, does FD Monitor support multiple applications sending messages to one monitoring recording system?
Yeah, I had a bit of a look at that during the session, and it looks like it does. Obviously, it'll have to sort of listen on the same port that we set up for FD Monitor, which is the default 8050, but that looks like it seems to work okay.
I guess you could start two different monitors on two different ports or multiple ports as well.
Yeah, absolutely, yeah. I guess probably one of the things about it is if you've got all of the logging switched on, the messages can get quite verbose in that monitor. So looking through and seeing sort of which is coming from which app may get a little tricky from time to time. So perhaps the second monitor on a different port number might be a good option.
Okay. And Robert also asked, if you have multiple machines, or even one machine, do you know where the messages are coming from? Does it get the IP address or machine name of the sending?
Yeah, that's a very good question. I'll have to dig into a little bit more, but the default behavior of the monitor doesn't seem to show the machine name directly when you've connected up. It shows that a client is attached and gives you the directory of the executable that it's running. It doesn't specifically state the IP address that it's running from. As you sort of go through the logs and get down into the driver details, you can see a machine name from the client ID, but it's not very apparent when you first look at it. So I'll just check with Dimitri if there's any other switches we can enable to see that detail.
Okay. Then you can add those to your blog or post or article about this stuff.
Yeah, will do.
Richard's saying, if I understand this correctly, tracing log file are used during development stage and not when production stage. And you mentioned you could have options in your application to tell your users or customers, maybe menu item or whatever, INI file flag or something, to turn on and off if you're trying to see what's going on in production environment as well, right, Damien?
Yeah, absolutely. Great question again. You know how a lot of applications you sort of can run things up in debug mode. You do a similar sort of thing with your application, is just sort of have a command argument like -debug that we look for sort of in the main sort of set of arguments, and then if we see that, we can just set tracing to true on the appropriate monitor component that you've got. Ideally, you know, as I said, we don't want to be running this up continually in production because of the amount of traffic that we're logging, which would sort of drag down performance of the application. But if you've got that as a switch there, as a way that your customers can kick it off, then that's a very neat way of handling it.
And a couple of people asked about, does this work with Delphi and C++? And the answer is yes. And then Ken chimed in that these components for FireDAC are also in the Pro, not just the client-server add-on or the Enterprise and above. And the answer is yes, in the sense that FireDAC also comes with a Pro for connecting to local databases. You need Enterprise and above or the client-server FireDAC add-on pack if you want to talk to remote databases. So yes, it's also in the Pro if you're talking to local interface, local SQLite, local Ivy Lite on Windows, and whatever. So yes, it's really part of FireDAC. Just as you have the access components like FD connection and so on, you'll see these monitoring and tracing components as well in the component palette, the non-visual controls. So it's all there for Delphi and C++. I think the monitor program is binary. I don't know if we ship the monitoring source code. It may be just a Windows executable. I have to go look and see if the monitor source code, if you could rebuild it for Macintosh, for example, or something. I don't know. But
yeah, I mean, it looks like it's just a binary, but I haven't looked very deeply into that. Yeah. So yeah, perhaps there is some source we can just recompile.
Yeah. Alan asked, will this tracing work with the DBX bridge driver? And for that matter, I could say the ODBC bridge as well.
Yeah, that's a very good question. I believe that this would work because, I mean, we're just simply pointing to the FD connection, and the FD connection is where the monitoring happens. So if you're specifying your connection out of the TFD connection component, then yeah, you would see it It'll be interesting to see what details you actually get. What's surfaced via DB Express or via ODBC, but yes, you should be able to monitor those at those levels.